All right, so we're looking at Unit 3, Lesson 1, homework number 1. So here we're given a position function, s with respect to t, and they want us to find the velocity acceleration, determine when the object's moving toward and away from the origin, when it's speeding up, slowing down, and then they ask what's happening to the velocity over time, which I'm going to interpret in a more mathematical way. So essentially they're asking me what is the velocity doing as time approaches positive infinity, as it's getting larger and larger and larger. Okay, so let's start with finding the velocity, which is just the derivative of the position function. So 4t cubed minus 20t, and of course the plus 9 goes. And then we'll find the acceleration, which is just the derivative of the velocity function. So that's going to be 12t squared minus 20. Okay, so what do we want to do? So if we want to move toward and away from the origin, we want to determine when that's happening. Let's let our participants here tell me what I need to be looking at. So what are the things or thing that I need to look at if I'm determining when something is moving toward or away from an origin point?
The sign of the function of the times, so like factor it, get those times, and then find the interval.
Okay, is it enough to be working with the position function? No. What else do I have to be working with? Yeah.
So with the velocity.
There you go. So when we're talking about away and toward the origin, we have to work with both of these functions, but as somebody said, it all has to do with the signs of the functions at any particular time. And then similarly, we're going to see that in C, speeding up, slowing down, we have to look at the velocity and acceleration. Okay? But of course, if I want to determine the sign of these functions, I'm going to have to start by factoring them so I can determine when they're going to be equal to 0. Here, everything's a polynomial. Perfect. I don't have to worry about when these things don't exist. All right, so let's do the first one. So we want to solve 0 is equal to t to the 4 minus 10t squared plus 9. And hopefully we're seeing that that factors very nicely because it looks a lot like a quadratic. So that's just t squared minus 9 and t squared plus minus 1. Okay, which again, both factor nicely. That's just t plus 3 and t minus 3, t plus 1, t minus 1. Okay, so these are the values we're going to be interested in. And then we'll work with the velocity function and see when that's equal to 0. So here we've got 4t cubed minus 20. So I might as well factor right off the bat. I can factor out of 4t. And then here I'm just going to be left with t squared minus, and 20 divided by 4 is going to be 5. Okay, so here we're left with, obviously here t, I forgot to write that out, is going to be plus or minus 3 and plus or minus 1, whereas here t is going to be equal to 0 and t is going to be equal to plus or minus square root of 5. Okay, so I just start with these here. And I'm going to set up my number line or my number lines, and the way that I at least suggest that you do that is you place them one on top of the other with the same scales so that you can just literally read the answer off the graphs. But before I start that, am I necessarily going to be considering all these values? No, yeah, exactly, because we're dealing with time, and so that means I'm only starting at t equals 0. Okay, so I'm starting let's do s of t here, so I'm starting that at 0. Okay, and let's see what we need to put on there, where we're going to need 1 and 3. Okay, here we've got the 0, that's fine. And here, root 5 and negative root 5, well, we know that's, a little bit bigger than 2. All right, so we know we're going to need a 1 here. Okay, and we'll put a 2, 3 here. And then for the velocity, again, starting at 0. And the only thing that we're really interested in here is positive root 5. Okay, so that's going to be a little over 2. Okay, and again, nothing stops you from finding an approximation here. Since this is an application question, in the end, it makes sense to be giving the answer in approximated form. Okay, so now I just do what we always do. Now, notice here that I've got a quartic with a positive leading coefficient, okay? And that's maybe the only reason why I might have kept those other two, because I don't really feel like testing any numbers. So what I'm going to do is I'm just going to kind of continue my number line and know that I've got the -3 and the -1, because this is a quartic with a positive leading coefficient, which means my function is going to go from positive to negative, back to positive, okay? And I know it's going to do something like that. So see, I didn't actually have to do any work here because I know that in this area from 0 to 1, even though it starts at -1, I'm only interested from 0 to 1. To 0 to 1, it's positive. In this interval here, it's negative, and then it's going to be positive again. Okay? And similarly, okay, when it comes to the velocity function, I have a cubic with a positive leading coefficient. So I'm going to pretend that I'm extending my number line. Somewhere here, I've got negative root 5, and we know it's going to go from negative infinity, and then at 0, it's going to cross, and then it's going to cross again towards positive infinity at root 5. And so here, in this portion here, it's going to be negative, and in this portion here, it's going to be positive. And now what's nice about this is I can just read everything off my graph. All right, so let's do toward. Okay, and we know that when we move toward the point of reference, we're going to be looking for where the signs are opposite to each other. And what I see here is between 0 and 1, the signs are opposite to each other. Okay, 0, 1. Okay, and then here, where else are the signs opposite? Well, it looks like it's between root 5 and 3, where we have positive and negative. Okay. And here, of course, this is in seconds. Can somebody tell me whether it's in seconds or minutes? Seconds. Okay. And now when we're looking for away from the origin, we just look for where their signs are the same. So here they're the same. They're both negative here between 1 and root 5. And then they're also the same from 3 to infinity. Okay, now you might sort of say, well, it doesn't actually go for infinity, but they haven't given us any, they haven't told us that it's for 10 seconds or 50 seconds or a million seconds. So this is how we're going to present it. And if the experiment ends at a particular point, then that's perfectly fine. All right, any questions on this so far? No. Now, you notice how I did my work on the side. Because guess what? I don't want to redraw my velocity graph since I know that in part C, I'm going to need to use it to find where it's speeding up or slowing down. Okay, so I might as well put my third graph right here. Oops, A at t. Okay, and here, A at t is a quadratic. So here, let me do some work down here. So this is part C. So A at t, we're going to make that equal to 0. And what do we have? We have 12t squared minus 20. So now I can move everything up here. So let's divide by, make our lives a little simpler here. So I guess we can divide by 4. Okay, so 4. And then what are we left with? We're left with 3t squared minus 5. Okay, so that means that 3t squared has to be equal to 5. T squared has to be equal to 5 over 3. And so t is equal to plus or minus root 5 over 3. Okay. Now this is where root 5 over 3, well, this is bigger than 1 and less than 2. So I know it's going to be like a little bit bigger than 1. Again, if I felt like it, I'd take my calculator and I'd actually find an approximation, but we can figure that out. And again, we don't really care about the negative root 5 over 3, except for maybe sketching my graph. Okay, so here's my 1. So we know it's going to be a little bit bigger than 1. Okay, so there's my root 5 over 3. Okay, and again, if I kind of extend it over and know that I've got another 0 there, and I see that I've got a quadratic with a positive leading coefficient, so of course my graph is going to look like this, quadratic, and so it's going to be negative on the left and positive on the right. Okay, and now I'm going to do the exact same thing as I did before. Okay, so first I'm going to look at speeding up. Okay, and here, this is where velocity and acceleration have the same sign. Okay, so where do they have the same sign? Well, have the same sign in this area here where they're both negative. So between 0 and root 5 over 3. Okay, and then here they have the same sign. It looks like after root 5. So root 5 to positive infinity. Okay, and the only time they have opposite signs, so where it's slowing down, okay, the only time they have opposite signs is in this little area here from root 5 over 3 to root 5. And of course, both of these are in seconds because we're only interested in the times at which this happens. All right, so any questions on these here? No? So now what we can do is go to the last question, which asks, I believe that was what happens to the velocity over time. Okay, so here, what happens to velocity over time is essentially just as we had said already, the limit as t goes to positive infinity of the velocity. And here, since the velocity function, we'll write that out again, is given by 4t cubed minus 20t. Okay, we know that this is a cubic, again, as we had said, with a positive leading coefficient. So we know that that's going to be approaching positive infinity. Okay, and I just want you to remember that I'm writing equals positive infinity, but we recognize this is an infinite limit, which is not an actual limit. It's just notation to represent that it's approaching positive infinity. All right, so any questions on this here? No? Okay, so let me shut this down.